making a video. Okay, so I felt quite accomplished after doing this question. Okay, so a rectangular garden has a diagonal length of 13 meters. If the perimeter of the garden is 34 meters, what are the dimensions? Okay, so what we're doing here, perimeter is what kind of equation do you think?
Side.
Yeah, so like that behaves kind of in a linear fashion, would you agree? What's the exponent on any of the perimeter equation? Wait, that's okay. We'll park that question for a second. We'll write the two equations and then we'll discuss the differences between them. Is that okay? So we'll write the two equations. First thing, what I want to do though is draw yourself a little picture. Oh, it's not gonna, anyway. X, Y, everyone happy? And then it said something about, I used X, Y purposely. You can call it W and L if you want, but I've called it X and Y for a reason. Okay, so there's your rectangular garden. Okay, and has a diagonal length of 13 meters. Okay. Dylan, what's the, because you already offered the answer, what's the perimeter of this garden? If we've chosen the variables X and Y.
Oh, 34.
Yeah, and so how do I model that with an equation?
2x plus 2y.
All right, 2x plus 2y is equal to 34. Is that okay? Okay. Now, all of that here, I'll clean that up actually. I'm not too happy with that. 2x plus 2y. Is everyone okay with the fact that if I factored out a 2, I'd have x plus y is equal to 34? You okay with that? And then I could divide both sides by 2 to get rid of that 2 out front. But what I do to one side, I got to do to the other. So I get x plus y is equal to 34. Sorry. I was thinking. Fair enough. Sorry. Fair enough. I was thinking about the next thing, the next question coming. I wasn't thinking about that. I have a really good question to ask you as a result. Okay, so if I could take this equation. Everyone agree yes or no. Hopefully we don't get a huh this time. Are we happy? What kind of graph would that produce? I was just trying to put a little bow on this whole lesson here as to what we've done on Friday. Ricky?
Linear graph?
That's a linear graph, right? That's a line. That's y equals mx plus b. Okay? It's just a straight line. Has a y-intercept of positive 7. Actually, it'd be going the other way. Y-intercept of positive 17 and then a slope of negative 1. Okay? Now, that's one equation. Okay, when we did substitution in the past, you needed 2 equations to solve for 2 unknowns. Okay? So we have to develop the other equation. Now, this is the kind of part of the question that I felt a little bit accomplished after figuring it out. Because I didn't have solutions for this. So I had to sit down and figure it out. What's the other equation? Given the information that I have. This was a harder one. This is why I felt a little bit accomplished. Let me just do something. I'm not gonna say any words. I'm just gonna do something and see if it triggers anything. Ooh, that was good. I didn't intend for that to happen. Trigs something. That's funny stuff. What's that? It's a triangle. What do I have in triangles? Or with triangles? It's a famous equation. Pythagorean theorem. So we can say, we know x squared plus y squared is equal to r squared. In this case, it's 13 squared. So I get x squared plus what am I going to put in for y? Yeah, I'm going to substitute 1 into 2. I'll write a 2 here. Okay, so I'm going to say, I'll highlight in a sec so everybody can see where it came from. You have this piece, this pink piece that I substituted in for y. You see that? That's the part. Well, I didn't know I had it right until the end of the question, but I felt pretty good after doing that, recognizing it for what it is. Okay. So now I'm just going to expand that pink piece, and then we're going to see what happens. Okay, so just be careful with some of the expansion. Okay, so remember, we get x squared plus negative x plus 17 times negative x plus 17 has to equal 169. Okay, and we're just going to expand this out as we've done in the past. So we get x squared minus x squared minus 17x plus another minus 17x, and then 17 times 17 is 289. Oh, did I make a mistake?
Yeah.
Yeah, what is it?
You need to make a positive x.
Yeah, this one here. Negative x times negative x is positive x squared. I caught that because the x squared piece shouldn't zero out.
Would you put equals 169?
Well, I'm not done yet. Okay, it doesn't have to be equals 169 either. What could I do? In anticipation of what it is I'm doing. Bryce? Yeah, I'm gonna take 169 away from both sides as well. And that's all gonna equal 0 now. Okay, and I just have to clean it up, and then I'm gonna get something that I should be able to work with. Okay? So by clean it up, I mean collect all the like terms, right? And so x squared plus x squared is gonna be 2x squareds minus 34x, and then plus 60 has to equal 0. Okay, I'll hit stop there, or like a pause for a sec, make sure everyone's good with how that came to be. Okay, what am I doing? I'm looking for what? There's only one variable here now. That was the point of the substitution work that I did 4 lines ago. Okay, we wrote something in with respect to the other variable, and then I substituted it into the other equation, so that now I only have one variable. What's the variable I'm looking for? X, right? It's written as a quadratic. I have a skill set to solve for x when it's written as a quadratic. Okay, I'm going to check the easiest one. What's the easiest way to solve for x here? If it's written as a quadratic. Again, a good segue into what we're heading into this week. Jacob?
Wait, no, other question. How is 289 minus 169 60? It's 120.
Oh, that might. Oh, I'm ahead again. Sorry, I'm ahead of line again. Sorry. You're right. Okay, thank you.
Well, I know, yeah.
Sorry, I was ahead one line. I looked in the wrong spot.
Now, no.
Now you know what to do. Right, that's a good trick. Actually, no one was answering the question, so that's a good like prompt as to what we should do next. What are we doing next, Jacob? Do you know?
Dividing all by 2.
Yeah, just factor out that 2 out front and turn it into a simple trinomial. That's good. Maybe I did that on purpose, Jacob. Thank you. We'll go with that.
Okay.
Now what can we do? We like questions like this, right? Because the coefficient in front of x squared is 1. It's a simple trinomial. You can find two numbers that multiply to 60 and add to negative 17. Owen?
Negative 5, negative 12.
Negative 5, negative 12. Everyone happy with that? So the two numbers that work are negative 5 and negative 12. And I like simple trinomials because as soon as I find those two factors with a simple trinomial, I can just write it after the variable. Okay, and something interesting happens there. So I can say x minus 5 equals 0 and x minus 12 equals 0. So x is going to equal 5 and because of the nature of this particular question, if you found the length, then you have also subsequently found the width as well. Just because of the nature of this balance game, right? If 1 is 1, like if 5 is the length, then the width has to be 12, and vice versa. We see? So those are actually your two dimensions that satisfy all these conditions in this question, right? These would be the dimensions. Now, if you didn't believe me, because I have made a couple mistakes today already, if you substituted those two values in to solve for y into this equation back here, this linear one, as we practiced doing last week, you would get, if I substitute in 5, I'm going to get 12. And if I substitute 12, I will get 5 into that linear equation. So just to prove it to you, y is equal to, if I substitute 5 in, I get 12. And if I substitute 12 in, okay, so those are your two dimensions. I suppose, therefore, you could write a therefore statement. These are the length and width of the garden in meters.